Okay, welcome back to lesson 5.3. This is example 1, part B. So with our first example, I just want to mention really quickly that I forgot to state that there was no oblique asymptote. And we know that there's never going to be an oblique asymptote at the same time that there is a horizontal asymptote. So it's sort of implied, but I just want you to state it when the question explicitly asked if there was an existence of an oblique asymptote. All right, so for this question here, we're actually going to factor first, which was our little hint, right? The first one was a linear equation over a linear equation. There was no factoring to do, but this one there is. So we're going to start by factoring the top and factoring the bottom. Now, you might want to do that factoring separately off to the side. For instance, with the numerator, it's a decomposition factoring. So the numerator, I'm just going to pull it off to the side and factor it. I'm looking for two numbers that multiply to -4 and add to -3. So those two numbers are -4 and +1. And so I can decompose the middle term. And then I can group the first two. There's a common factor of 2x. Oops. There's a common factor of 2x, so I'm left with an x minus 2. And then with the second 2, there is no common factor, but I can always divide by +1, and that leaves me with x minus 2. So I've got the matching factor in the brackets, and then the leftovers after I divide that out. All right, so my numerator then is 2x plus 1. I'm just switching the order here. I'm not sure why. I really didn't need to. And then in the denominator, this is a simple trinomial because there's a 1 in front of the x squared. So I don't have to do all of this nonsense. I just need the two numbers and then I can pop them right into the brackets with the x's, right? I already know that the answer is going to look like this. So I'm just asking myself what are two numbers that multiply to 6 and add to -5. And that's going to be -2 times -3 will give me the +6, but add up to -5. So those are my two numbers. And so I pop them in. And this is why we were factoring. First of all, I need them both factored later on to find the x-intercepts and the vertical asymptotes. But one of the other things I want to check for right away is there a factor that cancels? And in this case, there is a factor that cancels out the x minus 2. And that tells me that for the rest of the question, I can just deal with the leftovers as long as I remember that there is going to be a hole at that canceled factor. So there's a hole wherever x minus 2, that factor that we canceled, equals 0. So there's a hole then at x equals 2. So now for the rest of the question, I am just going to deal with g at x, because the graph is going to look like g at x, which is the canceled version of my original function. So the graph is going to look like this, but there will be this hole at x equals 2, and that's what brings me back to f at x. So now just looking at g at x, I'm going to deal with the rest of the things that they asked me to look for. So x-intercepts, y-intercepts, and asymptotes. So remember, for my x-intercepts, I'm going to set y equal to 0. And remember that for the x-intercepts, it's always going to just be the numerator that I really care about. The numerator gives me my x-intercepts, the denominator gives me my vertical asymptotes when I set them both equal to 0. And so here I get x is equal to -1 when I bring that over, and then I divide out the 2. So there's my x-intercept. My y-intercept is going to come from when I set x equal to 0. Oops. So instead of using f, I'm going to use g. It would work actually if you were to use f again, the original, but I really only need to focus on this. And so what I'm left with here is 1 over -3, which is the same as -1/3. So two really tiny intercepts again. And then I'm going to look for my asymptotes. So for this one here, my leftover equation, and again, I could be thinking about my original as well, the degrees are matching. Which tells me that I'm just going to divide the coefficients. And again here, I could be thinking about the coefficients of the original, 2 over 1, or I can be thinking about the coefficients of my canceled g at x, 2 over 1. So the horizontal asymptote is at y equals 2 over 1. I'm just showing my thinking here, like this is where I came up with the 2. I actually divided these values, and so my horizontal asymptote is at y equals 2. And this means, of course, that therefore there's no oblique asymptote. So I'm just addressing that part of the question where they did ask me to think about it. Now, the only thing I think I have left that I definitely need to talk about is the vertical asymptotes. And so for the vertical asymptote, I'm looking at the factors that did not cancel in the denominator. The canceled one was a whole. The non-canceling one, that gives me my vertical asymptote. So it's where is that remaining factor equal to 0? And so, of course, it's x equals 3. So we've got a couple of pieces of the puzzle here. Remember, x equals 3 divides my graph into two different sections. On the left of that section, I've got an x-intercept at x equals -1/2. I have the y-intercept at x equals 0. So I have 2 points over here. And I also actually have the whole x equals 2 is on the left side. So I have a lot of things going on the left side of the vertical asymptote. I want to consider what's going on the right-hand side before I choose my scale. So I want to pick a couple of points past x equals 3. I'm going to choose, so these are just my extra points so that I have points in both sections of the graph. I need 2 points past x equals 3 because I don't have any yet. I'm going to choose 4 and 5, but again, you could choose 6 or 7. So I'm going to plug that in, and you could be plugging it in if you want to F or to G. I'm going to use G here just because it simplifies my life. So I'm going to be plugging in 4. So that'll be 2 times 4 plus 1 over 4 minus 3. And so I get 9 over 1, or just 9, and then G at 5. And so here I get 11 over 2, or because we're graphing, you could be thinking about that as 5.5. Okay, so now I can kind of see what I need my y-axis to look like. So my x's, my biggest number is 5, and for my x's, my smallest number is -1/2. So it kind of tells me where I want that. For graphing the y values, though, I need to see up to 9 and down to, is it -5? Oh, why? How do I know it's -5? Because when you have a hole, you have to figure out, well, where is it on the graph? So I forgot about that piece. I need to be able to plot this hole. So I need to know what is the height of the hole. I know it's across at x equals 2, but to find the height, I'll just plug 2 into my equation g at 2. And I should be doing this after I define g at x. Oops. And so here I get 4 plus 1 is 5 divided by -1. So I get -5. So therefore the whole is at 2, -5. There's my y value. So I'm thinking about all this stuff when I'm trying to come up with my axes and where to put it. Remember, my y values I needed to see down to -5 and up to +9. So I do need to see more up top and less underneath. So I'm going to put my axis somewhere like here. And then thinking about my x values, I needed to see to 5. And then I think the smallest was -1/2. So I don't need to see very much on the negative side of the x-axis. So we'll label those. And then we're going to come up with our scale. So unfortunately for the y-axis, I do have to use 1 square is 1 in order to make it up to 9. If you were using different grid paper, you could maybe make your grid a little bit bigger. And then for the x's, I think the biggest one I chose was 5. So I can use just 2 squares is 1. All right. So now we're going to start to add some stuff to my graph. I want to add some asymptotes. So I know that I have a horizontal asymptote at y equals 2. And I have a vertical asymptote at y equals 3, or sorry, at x equals 3. And then I'll start to add some points. So again, we've got that hole. I need to add the hole. It's over at 2 and down at -5. So I'm going to make that a really big open circle so that my teacher can see that I know that there's a hole there. And then I'll add my x-intercept was at -1/2. And my y-intercept, so remember now this is 1, and my y-intercept was at -1/3. And so I've got these 3 points, and I'm just going to get closer and closer to the horizontal asymptote, connect through those dots, and then closer and closer to the hole, passing over the hole, and then closer and closer to my vertical asymptote. All right, and then on the right-hand side of my vertical asymptote, we came up with 2 points. At 4, the height is 9, and at 5, the height is 5.5. And then again, I can connect these guys, getting closer and closer to the vertical asymptote, and then getting closer and closer to the horizontal asymptote. And there's a lovely picture of my graph. And this is the graph of f at x, right? Because it includes the hole. Without the hole, if I were to draw right through there, that would be the graph of g at x. All right, and that's it for today's lesson. I hope you enjoy the homework.